Hello everyone and welcome to my YouTube channel. My name is Saksham and this is episode 3 of Threat Detection Lab series. So in this episode we'll be going over the logging architectures. So there could be multiple different kind of logging architectures that you can build and different pipelines that you can build basis your use case. Here we'll be realizing few of the use cases and understand how this pipeline actually works in practical scenarios, and we'll also see how these tools that we'll be installing on different VMs can be used to ship data from the source to destination, right? So we'll quickly go over the architecture diagram that we have here. As you can see on the screen, there are two different logging architectures here. One of them is based out of Elastic and another one is based out of Splunk. And both are really good platforms if you want to choose a platform for building a threat detection lab. But essentially, I don't want you to limit over one platform and go and explore as many platforms as possible, because you're here for conducting research and understanding how these platforms actually work. And that is one part of security, right? In threat detection engineering, you should be understanding how the platform is able to support your logics and analytic. So don't limit yourself to one of these. Go and explore all of them, and essentially we'll see how to build a pipeline that can help you send data to whichever platform you want to choose, and we'll build a more comprehensive pipeline. But here, for starting, you can actually see there is a Splunk-based detection lab where you have very simplistic routing path. You have Sysmon and native Windows logging, that is you forwarded via Splunk-universal forwarder to the Splunk platform. Or if you want to start building off your Elastic based threat detection lab, you can use multiple different technologies that Elastic Agent has to offer as integrations, and then you can use it to send data to Elasticsearch and use a Kibana SIM module to have a detection based lab, right? SIM based lab or SIM in your disposal. So these are the two ways how you can build a detection lab. But there is a vendor, as you can understand, there is a vendor lock-in going on here, right? If you choose any one of them, you are actually being logged out of the other platform. So as I mentioned, we don't want you to lock out of one platform. So we'll see how we can build more complex architectures, right? If we can build more complex architectures where we have multiple different logging pipelines, we'll go over each of them one by one and understand what is the advantage of one over the other. Okay, so as you can see on the screen, we have 4 different logging architectures which are complex in nature and allows you to forward data into multiple platforms. We'll go over all of them one by one and try to understand what advantage or disadvantages do they offer, and select one of them that we would like to build in later labs. So as you can understand here, there are multiple sources that I want to take into account for logging data, right? We need OS query for forensic capabilities. We need an EDR. So the EDR of the choice that I have here is Elastic EDR. It is a free EDR that you can use and has really good capabilities. We do want Sysmon, right? Sysmon is essential. Why do we want to have Sysmon apart from EDR when we already have an EDR? The answer is again the same, right? We don't want to lock onto one product, and there should always be a secondary product that you would be using to contradict the result of the first one, right? Otherwise you're having a bias, right? We don't want you to have a bias. We also want to have packet beats to have some network telemetry and network data that will be flowing through. And of course we'll be using Windows native logging to log Windows native logs, security system application, right? Now to ship all of them, the agent of choice here is Elastic Agent. Elastic Agent does why so again your question would be, why Elastic Agent, why not something else? You are free to choose any agent of your choice. You want to do FluentD, you want to do FluentBit, you're free. You want to use OpenTelemetry, you're free to use any one of them, right? I'm using Elastic Agent because it's easy to configure and it's easy to integrate. So, and since Elastic has stayed along in this pipeline and observability area, a lot of products that are built already have integrations with Elastic, right? So Logstash, Filebeats are some of very robust products, and Elastic Agent is essentially a new gen product of that is built over Filebeat and Logstash. So essentially Filebeat, right? So Elastic Agent has robust integrations if you talk about the backend. So I'm using Elastic Agent. So Elastic Agent can actually operate in two modes. One of them is standalone and another one is managed, right? So what we can do here is we can have an Elastic Agent in standalone mode, right? Not what is standalone? It's not reporting to any fixed Elastic cluster or any Elastic cluster or a fleet server that manages it, but is running in a standalone mode with the help of the configuration that we supply to it. Using this, we can send data to a pipeline solution. So there are two pipeline solutions or three different pipeline solutions that I would recommend. One of them is, of course, very popular, Kafka. You can use Kafka to build out your pipeline. Another one is Logstash, again a product by Elastic, but Logstash has an open version as well. So if you are interested in open version, you can use that. Logstash free is also available, which is really good. So you can go ahead and choose any one of them. What I have here is basically a Cribble Stream Cloud Community Edition. So Cribble Stream allows you to basically route 1 terabyte of data per day in their community edition, which is really good amount of data, right? And using this, it's very easy to intuitively move your data, ingest your data, manage your data, and move it to a different destination. So I aim to use Cribble Stream platform here. Cribble Stream has a cloud deployment if you sign up for the community edition. So if you go with Cribble Stream, you can actually send data to multiple different sources. Now the disadvantage with Cribble Stream Cloud Community Edition is once you move data to your cloud, there's a blockout, right? You cannot move data back to your on-prem devices easily. There's no way to easily route. You don't have a static IP, right? You don't have that kind of a setup where where an instance is publicly reachable. So your data once moved to Cribble Stream Cloud Community Edition will not be able to move back to your on-prem architecture or on-prem lab environment, which would be Splunk or Elastic. Yeah, but you can move your data to other cloud-based solutions, right? For example, you can route data from Cribble to Grafana Cloud via a free plan that you can use, or Azure Data Explorer. It also has a free cluster that you can use, or Cribble Data Lake for that matter, right? It's a data lake that Cribble offers you and can store up to 50 GB of logs. So this is one of the architecture that you can build out. This is essentially great if you don't have a virtual machine for specifically hosting sims. Let's say, for example, you are very low on amount of RAM that you're using. Suppose you have only 8 GB of RAM or 4 GB of RAM. You can at least run one VM with Elastic Agent and Sysmon installed on it, route all your data to cloud, and then move into free solutions. So that way you learn Grafana, Azure, and Cribble, and you have almost all of the capabilities that you need to learn or need to operate for an SIEM. And that way you only are operating out of one virtual machine, but essentially have a cloud SIM with you. So this is helpful there, but this has a disadvantage that we do not have on-prem destination. Another disadvantage that you can think of is basically Grafana also has limitation. So all of the cloud SaaS platforms that offer community edition will have some kind of a limitation on the amount of data that you can ingest, right? So Grafana has 50 GB, Azure Data Explorer free cluster has 100 GB, Cribble Data Lake as of today has 50 GB, right? So you are essentially locking out to 50 GB, which is more than sufficient for your use case, but yes, you are locking out. Let's move on to the second architecture. So it's essentially the same architecture as above, but we have replaced Cribble Stream with Logstash/Kafka, any one of your choice. That is hosted on-prem. The advantage here again is Since it's on-prem, it can route data to your on-prem environment, right? To your local network and locally hosted solutions. That would be a Splunk and Elastic. And it can also send data to your cloud hosted platforms such as Grafana, Azure Data Explorer, or Cribble SaaS solutions. So this way you have a mechanism to basically send data to different platforms of your choice. But the disadvantage that you have here is we have Logstash and Kafka, that is a management overhead, right? We don't want to have that management overhead and want to keep it as simple as possible. Cribble is a UI based solution, so it's easy to manage data there. It's easy to collect, transform, and route data via Cribble rather than doing it via Logstash or Kafka, which is difficult. So again, to resolve this conflict, what I want to do is introduce Cribble Stream here. But this again, as you can understand, is an overhead of managing Logstash, Kafka, and Cribble Stream. But the advantage here that you would get here is your logging on cloud is resolved here, and your logging on prem is also resolved, right? So you get both logging on cloud and on prem with management layer and on Cribble, right? Again, this doesn't look appropriate as much, right? So we can actually skip this. This introduces a lot of overhead, resolves for a cloud logging pipeline, but your on-prem is still difficult. um, it's not. So when I say difficult, I just want to clarify, you can still manage Logstash and Kafka, and that is a good learning aspect of security. You would be learning how to manage pipelines, how to manage queues, how to manage different topics and all of that, which is good if you are really interested in building pipelines, and your day in day out job might be related to managing platforms or building pipelines and handling large amount of data. But if you're not, and you're just focusing on the security detection and security aspect of it, I would rather not choose this option and go on with basically a fourth option. So a bit of research revealed that Cribble also offers on-prem solution as part of their community edition. So you can basically deploy Cribble in a container locally, and that would enable you to ingest data from Elastic Agent and route it to almost any solution of your choice. And with this, you actually get capabilities such as easy management, easy routing and collection, and data forwarding to almost any platform of your choice. So this is the architecture that we aim to build as part of our later comprehensive labs. So in one of the videos later in this series, we'll try to reach this state. But for this video, we'll just start off by building the very simplest architecture, that is Splunk-based Detection Lab, and we'll quickly get started there. So we have all the three VMs that we set up in the last video, the firewall, the logging server, and Windows 11 box. We'll go to the logging server. And one thing that we would need for this is basically, as you can understand, is basically a Splunk platform. So we need to set up Splunk here, and we need to set up Sysmon on the Windows box, right? So we'll first try to set up Splunk. We'll go to a logging server, and we'll be doing a container based Splunk deployment. So if you just go to the browser and let's search for Splunk free, can go to Splunk, and you'll have to sign up. So I have already signed in, so I'll just go to my dashboard and Splunk Enterprise. As you can read here, index up to 500 MB per day. And after 60 days, it converts from a enterprise license to perpetual free license that you can run infinitely to basically serve your use case. Now this is what we want, right? We want to index up to 500 MB per day on this Splunk platform and keep it available for our threat detection lab. So what we'll do is we will set up using containers. You can also go ahead and set up bare bones using Windows, Linux, macOS installer packages that they offer. For our use case, what we'll do is we'll basically use so if you go to Docker Hub and search for the Splunk image, we'll get Splunk official image that, and there are instructions that you can follow to basically set it up as a container. What we'll do is we'll first set up containers or Docker here. Let us see. We don't have Docker, so what we'll do is we'll follow Docker installation steps. Okay, there are a bunch of steps that are written here. We just need to copy and paste them to install Docker. It's easy to use containers because they are wrapped up with configurations and everything, rather than us following a path of installation installing it as a binary, then configuring environment variables and everything. It's far easy to use containers, and they're easy to manage. If you are very new to container, I recommend you keep Docker cheat sheet handy. Take a screenshot and set it as a desktop wallpaper or something. It has almost all the important commands that you would need as a beginner to acquaint yourself to get started with Docker containers on your local machine. This is really good resource to start with. Our steps as complete. There's one more step. If you do post install Linux, yes, post install for Docker engine, there are a set of steps that you need to perform to basically enable Docker to be running without sudo. Otherwise we'll always have to do sudo and then the Docker command. So we'll just run these steps as well. Perfect. Now if we run Docker, run hello world, that should run. Okay, it did not find the image locally. It will try to gather the image. And hello from Docker, it works perfectly. So now we have Docker set up on our logging machine. We'll now go ahead and set up or start setting up Splunk. We'll use Docker Compose. We'll use Docker Compose for this installation. As you can understand, this is a Docker command to run the Splunk, basically pull the Splunk latest image and run it. But the disadvantage here is, first of all, we are not getting declarative configuration. So the configuration is passed as an argument into the command line. So later when we want to change this configuration, it would not be possible. That is one. Another one is that there are some missing configuration for the Splunk to properly function and ingest data. So we'll use a declarative configuration via YML file to stand up our container via Docker. and we'll be using Docker Compose for that. Docker Compose is a command line utility that takes in a configuration in YML format and understands and run the defined or declared configuration to build your container, right? So what we'll have to do is we need to have a YML file. For the sake of this video, what I've done is I've simplified this. If you go to GitHub and basically my Git repository, THOR Detection Lab, this I'm trying to put all the helper scripts here. You can go to this file Splunk compose v2.yml. I'll paste the link in the description so that you can directly reach this. And this is the YML configuration that we'll be using to run the basically Splunk. So let's check if we have Docker Compose already. Yes, we do have Docker Compose available. So what we'll do is we'll have to save this YML file. We click on download raw file. We got this file. So now if we go to our terminal, clear things out and do let's check where that file is. It should be in downloads, right? So we'll do docker compose -f. -f actually is a flag that is used to specify the YML file. We'll specify the YML file. We'll say up and we'll run it in detached mode. That means we don't want the logs to be printed on the screen, but we do want the Docker Compose to run that configuration and build our containers in the back. So we'll just run this. It will start pulling the images and everything. Okay, as you can see, it has pulled the image and has created basically network volume and the container has started. So to check the status of the container, we can do docker ps and it will show that a container is running and the health is still starting. So meanwhile, while it is becoming healthy and it completely loads, we can actually go back to setting up Sysmon. But another thing that I want to show you here is you can do docker logs and your container name. So we just copy paste. You can see the actual logs that are printed by this, and this is really helpful for troubleshooting, right? So we'll just clear this out and then do docker ps. Still starting. Let's go to setup Sysmon. So we'll go to our Windows box. Okay, let's gather the binary for Sysmon. Okay, Sysmon is internals, version 15.14, and this is where you click to get the binary. Now Sysmon is a system monitoring tool, right? So it allows a lot of and gives you a lot of capability to collect data around process creation, network connections, changes to file time, and a lot of different events. All of this could be streamed to an event collection system, and where you can analyze them to search and hunt for threats. We'll be using this in the default configuration. However, you can also pass on a lot of different configurations into this Sysmon to enable and disable different kind of events, whitelist and blacklist different events. All of that is possible, right? So one of the really good resource is if you go to GitHub Sysmon modular, I think this is a really popular project by Olaf Artham. He has done a great job to build basically a lot of different configurations. You can basically run Sysmon config research, which enables a lot excessive telemetry for you. A really good configuration if you are into researching and collecting all of the data. Otherwise, Sysmon config.xml is a really good, well balanced configuration that he has published out for us to use. I would recommend that if you can go ahead and run this XML, or for let's for the sake of this video, let's try to set up this configuration, right? We'll just click on this and download this file. Okay, let's start setting up Sysmon. We'll have to extract the package. Okay, we'll go to terminal. What we need is basically terminal with admin, so we'll just need terminal with admin rights. Okay, let's cd to this location. Okay, so let's move the configuration file also to the into this folder, and let's grab the installation command. If you scroll down, you will see this is how you install Sysmon and apply a configuration, right? So we'll use this. We'll be converting the command to Sysmon 64, and we'll be applying the Sysmon config.xml, right? Okay, the installation has completed. How do we verify this? Is by going to event viewer. Let's go to application and service logs. It will take a minute to load. Let's go to Microsoft, Windows. If we scroll down, we should be having something for Sysmon. Yep, Sysmon operational, and this should have all the logs, right? If you click on any one of them, you can see the log, and if you go to details, you'll get a well formatted log, right? So we have set up Sysmon. Let's go back to our logging server and check the status if our Splunk is up and running and in healthy state. We'll do clear, we'll do ps docker ps. It says healthy. Let's try to access it. We do 192.168.0 dot, or let's do localhost to 8000. Username will be admin, password will be what we have set in the compose file. So we'll do docker cat Splunk compose v2, and there we'll have the password. Copy this. Great. So now we have a fully functional running Splunk instance. Go to settings, licensing, and you see we have 500 MB of daily license volume, license for daily ingestion. This is good. So if you go back to the diagram, we have set up Sysmon, we have set up Splunk. Now we need to connect them via Splunk-universal forwarder. Basically use this to set up on Windows box to ship these two component or these two types of logs to Splunk platform for analytics. So we'll quickly get going there. Okay, so let's start setting up our Splunk Universal Forwarder. We'll go back to the Windows VM and we'll go to the Splunk site, trials and downloads. We'll log in. Do not save your password here. This is a VM where we'll be running malwares. We'll go to my dashboard. We'll go to Splunk Universal Forwarder and we'll download the 64-bit Windows 11. Awesome. So we have got the binary. Let's start installing it. We'll accept the license, an on-prem Splunk Enterprise instance. Okay. We'll click on Customize options. We'll let the location be. We can leave this because we are not having an SSL based instance. So we can click on next. We'll use the local system because we want the universal forwarder to basically have access to all the data on this machine and forward it to this machine, right? So basically Sysmon resides on this machine. So we'll use local system. We'll move next. In the Windows native logging segment, we will enable application security system. Let's do all, right? So we'll enable all kind of logs to be collected. We'll click on next. Just enter admin. It will generate some random password. So we are using a Splunk free instance, which is all-in-one deployment. So an all-in-one deployment has a deployment server, indexer, everything all in one. So we'll just give the IP of our Linux machine that we have. So we'll just quickly go back and check the IP. If config pynet 136 0.136.089 136.9997. Install this. If you can finish, we can go to the task manager and go to the services, and we should be able to see Splunk forwarder as a service running. Another thing that we can do is we can go to C, program files, Splunk Universal Forwarder, etc, apps, Splunk Universal Forwarder, local, and you should have a file name inputs.conf. If you open with Notepad, you would see the configuration that enables forwarding of all of this kind of data. Forwarded event setup, system security application. Now one configuration change that we need to do here to ingest Sysmon is basically we just need to copy this, paste. Instead of application, we will have to replace this with the Sysmon directory. So we'll put this as Microsoft Windows System, Sysmon operational. Right, so we'll replace this. Rest all settings would be same. We'll just save this file. We'll not be able to save in the current directory because of permission issue. We'll save it into documents. Change to all files. Save. Okay, it's saved as a text document. We don't want it to be as text document. It should be conf file. File name extensions, and we'll just rename and remove the extension. It has got double extension. Now it is perfect. Conf file, we'll just copy and place this file, replace the file in destination, continue. So now we have, if we open this, we have the edited file here. We'll just go back to the task manager and restart the service so that the Splunk forwarder actually picks up the new configuration. So it's running. Perfect. Let's go back to our logging server and our Splunk. We'll go to settings, data inputs, and we'll go to Windows event logs, forwarded inputs. We'll click on add new, and it should show the Splunk-universal forwarder reporting here, right? It should automatically come up. So we should be clicking this. New server class name, we could put anything, and I'll just put THOR Lab. Click next. We'll select add all. We'll do next. Index default, review, submit, start searching. Awesome. So now, as you can see, we have already 17,540 logs here. So all of our Splunk logs, Sysmon logs and Windows event logs are coming. Let's quickly create a table out of it to understand if we have all the events of interest. We'll just do table, or let's do stats count by to count and see groups of all the log names that we are receiving. Right, so as you can understand, Sysmon operational, application, security, setup and system, we have all of these 5 category of logs incoming, and hereby we should be having live logs, right? So if I do something here, say I ping 8.8.8.8, this should be a log. There should be a log here. So we'll just do Sysmon operational, view events, and event. Let's do let's table all the command line, and command line equal to star table command line. Okay, let's do verbose and give it a minute. We'll just click on view events. So as you can see, Sysmon has sent us process create, and we have parent image ID. We used CMD to call basically ping. So there should be a description and image, right? Ping was called by CMD and the exact command line. So if we can just table that, table task category. Parent image and command line. We have all that data. We'll just filter for that, where parent image or image is equal to star ping.exe. Right, so this is the command. So we have live data coming in, and that is validated. We are able to search and perform analytics on data. So the architecture here is now fully established, and you can start simulating some of the threats to see if you have events, or you can start performing some of the actions on this Windows box and understand how the events and logs are generated here. So this would be the most simplest architecture that you can build and start working with Splunk, learn Splunk and learn Splunk query language. And I'll wrap up this video here. In the next video, we'll start setting up the Elastic-based Detection Lab with more capabilities and more telemetries. So stay tuned and do follow and subscribe this channel if you are liking the content and the direction. I hope this video helped you and would be beneficial in your detection engineering journey. Stay tuned and see you in the next video.